A design rule check is a process where a rule verifies whether a layout meets the minimum width, spacing, and other design rules established for a given manufacturing process or its variation. To perform a hierarchical DRC at minimum, you need a process DRC rule file and a DF2 Virtuoso layout data, GDS2 or OASIS layout database. The DRC rule file comprises one or more rule files in PVL or other compatible formats. Each rule file can include multiple statements to include other files of the same format. When you submit a PVS or Pegasus DRC job from Virtuoso using DF2 Virtuoso layout data as input, you have the option to allow the tool to read the layout data directly or convert it to a GDS2 file and then pass the GDS2 file as input to PVS0R Pegasus. The primary outputs generated by PVS or Pegasus are the summary report file, ASCII violation report file, and output file in GDS2, OASIS, or OA formats. The output file contains the violation data, or the data created by PVS or Pegasus for fill. The data, rule processing information, runtime, and memory usage are output to standard output. You can redirect this information to a log file. LVS, layout versus schematic, is a process that involves extracting the devices, their parameters, and connectivity information from the layout data. The extracted data is then used to create a layout netlist, which can be compared to the schematic netlist to ensure that the layout design matches the original schematic. The layout netlist can also be input into a simulator for further verification. To perform hierarchical LVS, you need layout data in DF2, GDS2, or OASIS format, and schematic data in DF2 and netlist formats. The first step is to extract a CDL or SPICE netlist from the GDS2 or OASIS layout data. For schematic data, LVS currently supports CDL or SPICE and Verilog netlists. The rules file for this is the same as the design rule check. When submitting a PVS or Pegasus LVS job from Virtuoso, suppose you are using a DF2 Virtuoso layout data as input. In that case, you can either have the tool read the layout data directly or convert it to a GDS2 file, and then use the GDS2 file as input to PVS or Pegasus. Alternatively, if you're using DF2 Composer schematic data as input, Virtuoso CDL out exports the CDL data to a file and then uses that file as input to PVS or Pegasus. You can also provide Verilog and CDL files as inputs directly via the LVS run submission form or in the rule file. The PVS or Pegasus tool generates several outputs, including an extraction summary report file, soft check results file, shorts results file, extracted layout SPICE netlist file, when SPICE is specified, and pin swap results file. Soft checks and short results files are generated only if corresponding violations are found in the design. Additionally, a compare summary file is also created. These also provide information on data, rule processing, runtime, and memory usage displayed on the standard output. If required, you can redirect this information to a log file. Below is a list of output file names generated from PVS or Pegasus layout versus schematic, and their descriptions. Schematic versus schematic, SVS, compares two schematics or netlists. It is pretty similar to LVS. To run SVS, you need two netlists and a rule file. One of the netlists is usually extracted from the layout during an LVS run, and the other is the netlist from the original schematics, also known as the golden netlist. SVS supports CDL, SPICE, and Verilog netlists for schematic data. The rule file is the same as LVS. If you are using a DF2 Composer layout or schematic data as the input, Virtuoso CDL out will export the CDL data to a file. This file will then be used to input PVS or Pegasus. Alternatively, you can directly provide Verilog and CDL files as inputs via the SVS run submission form or in the rule file. PVS or Pegasus XOR utility, or LVL, layout versus layout, enables you to compare two layouts. To use XOR, you need a rule file, also called a rule deck, specifically designed to compare two layouts and the layout databases in DF2, GDS2, or OASIS format. The rules files required for PVS or Pegasus XOR are the same as those used for DRC. If you submit an XOR job using the XOR run submission form with a Virtuoso layout as input, the output data is written to a GDS2 file. This GDS2 file is then used as input for PVS or Pegasus because the tool does not support direct reading of a Virtuoso database. FastXOR allows you to compare the contents of two layout data files without a rule file. You can run FastXOR in two modes, cell and full. The cell mode can be significantly faster than the full mode. The minimum input to FastXOR is two input layout files, two GDS2, two OASIS, or one GDS2 and one OASIS, and a primary cell name. The primary cell name is assumed to be the same for both files. You can specify additional options if the primary cell name of one input file differs from the primary cell name of the other. When you submit a FastXOR job using the run submission form, the input is a Virtuoso layout. PVS or Pegasus will first output the data to a GDS2 file. FastXOR will then read all the layers from both input databases and compare them. If there are differences between the two designs, your error output is GDS2 format.